Hi student friends, in continuation with the previous video of Laplace transform, today I will discuss some problems based on standard results of Laplace transform. I will revise the points whatever we have discussed in last video. Laplace transform is defined by this formula, Laplace of f of t as integral from 0 to infinity e raised to minus st f of t dt, and we call it as f bar of s. A function of t is changed to a function of s, that's why it is called as transform. Then standard result for Laplace transform. Result number 1, Laplace of 1 is 1 by s, Laplace of e raised to at is 1 upon s minus a, s greater than a, or Laplace of e raised to minus at is 1 upon s plus a, Laplace of sin at is a divided by s square plus a square, Laplace of cos at s upon s square plus a square, Laplace of sin hyperbolic at a upon s square minus a square, s greater than a, Laplace of cos h at s upon s square minus a square, s greater than a, Laplace of t raised to n is with two results, gamma n plus 1 divided by s raised to n plus 1, or it is n factorial upon s raised to n plus 1 if n is a positive integer. Then I will discuss some more problems based on this standard result. Therefore, take the first. Find Laplace of sin square 3t. Therefore, sin square, for that we don't have any formula directly. Therefore, we have to convert this sin square theta. We know that sin square theta is 1 minus cos of 2 theta by 2. Using this, we get the value of sin square 3t as 1 minus cos of 2 times 3t. Therefore, 2 times 3t it becomes 6t divided by 2. Means I have converted this sin square in terms of cos, for which we have a Laplace transform. Therefore, taking Laplace on both sides, Laplace of sin square 3t means the Laplace of 1 minus cos of 6t divided by 2. Applying the properties of linearity, constant term we can take it outside, 1 by 2 outside, and Laplace of remaining, Laplace of first term 1 minus Laplace of cos of 6t. And then using the standard results, Laplace of 1 is 1 by s, Laplace of cos of 80 is s divided by s square plus a square, a is here 6, 6 square 36. Then we simplify it by cross multiplication. It is 1 by 2, 1 into this, we get s square plus 36 and minus this s square divided by s into s square plus 36, and therefore it is 1 by 2, s square get cancelled, it is 36 divided by, if you multiply it inside, it is s cube plus 36s, and dividing by 2 we get its value as simplified form, 18 divided by s cube plus 36s. Okay, this is the required result. Find, second problem, Laplace of cos square 2t. Again, cos square directly we don't have any result. Therefore, once again we apply the standard result. We know that cos square theta as 1 plus cos of 2 theta by 2, and therefore this cos square 2t is 1 plus cos of 2 times 2t, therefore it becomes 4t divided by 2. Okay, and then taking Laplace on both sides, therefore Laplace of this means the Laplace of this, applying linearity property, constant term I will take it outside, and Laplace of the remaining, Laplace of 1 and Laplace of cos of 4t. Okay, and therefore it is equals to 1 by 2 Laplace of 1, again 1 by s, Laplace of cos 4t, Laplace of cos 4t, again applying the same, it is s upon s square plus a square 4 square 16. Simplifying it by finding the LCM, 1 by 2 cross multiplication, s square plus 16 plus s square s into s square plus 16. And if we simplify it, s square plus s square we get 2s square plus 16 and divided by s into, or if you multiply it inside, it becomes s cube plus 16s square, 16s into 1 by 2. Therefore, multiplying it by 1 by 2, we get, here 2 get cancelled, therefore s square, 16 by 2 we get 8 divided by s cube plus 16s. Third example, find Laplace of sin cube t. Again, no result for sin cube t directly. Therefore, we have to use standard result. We know that sin cube theta as 1 by 4 sin 3 theta minus 3 sin theta. 3 sin theta minus sin of 3 theta. Standard result from trigonometry. And therefore, using this, we convert this. Therefore, sin cube t, I can write down as 1 by 4 3 sin theta, theta is here t, therefore sin t minus sin of 3t. Okay, and next step, taking Laplace on both sides, therefore Laplace transform of sin cube t means the Laplace of this, applying directly that property of linearity. Constant term I will take it outside. Therefore, it is 3 by 4 Laplace of sin t minus 1 by 4 Laplace of sin 3t. Okay, and therefore it is equals to 3 by 4. Applying the Laplace of sin at formula, it is a upon s square plus a square. A is here 1, therefore 1 upon s square plus 1 minus 1 by 4 Laplace of, again same formula, sin at. Here a is 3, therefore 3 upon s square plus 3 square 9. Therefore 3 by 4 we can take common. Remaining terms are 1 upon s square plus 1 and minus 1 upon s square plus 9. Okay, you can keep this as it is, or we can simplify it further by taking cross multiplication or LCM. 3 by 4 we cross multiply here, it is s square plus 9 minus s square plus 1 and divided by a product of these two, it is s square plus 1 and s square plus 9, and that is equals to s square get cancelled, 9 minus 1 we get 8, therefore 3 by 4 8 divided by s square plus 1 into s square plus 9. Okay, this is that result. Okay, this is equals to, if you divide by 4 we get 2 here, 3 to the 6 divided by s square plus 1 s square plus 9. Required Laplace transform for sin cube t. Similarly, find Laplace transform of cos cube 4t. Here, once again, no result for cos cube in that standard result. We take the help of the standard trigonometric formula. For cos cube theta, we have a result as 1 by 4. It is 3 cos theta and plus cos of 3 theta. Here the middle sign is minus, here it is plus. For sine we have sine term, for cos we have cosine term. And therefore, Laplace of cos cube 4t means the Laplace of converting in this form and then taking Laplace. Therefore, that 2 steps are performed as a single step. 1 by 4 times 3 cos theta, theta is here 4t, plus cos of 3 times 4t, therefore 4 3 is 12t. Okay, and then applying property of linearity, 3 by 4 constant, Laplace of first term is cos of 4t plus 1 by 4 Laplace of is cos of 2t, and then applying this standard result, we get 3 by 4. Cos of 80 Laplace is E s upon s square plus a square 4 square 16. 1 by 4 cos of 80, its Laplace is s upon s square plus a square 2 square 4. We can take we can keep this as it is, or we can simplify it further by taking 1 by 4 common. Therefore here it is 3s divided by s square plus 16 and plus s upon s square plus 4, a required Laplace transform. Then I will write down the defactorization formulas. 2 sin A cos B, 2 cos A cos B, and 2 sin A sin B. The result for 2 sin A cos B is sin of A plus B plus sin of A minus B. 2 cos A cos B, cos A plus B, cos A plus B plus cos of A minus B, and 2 sin A sin B, cos of A minus B minus cos of A plus B. This formulas for defactorization. Defactorization means product of sin cos is converted to sum of the terms. Then based on this we take this example. This is example number 5th. Find Laplace transform of sin 2t into cos of 3t. When we find Laplace of it, it is not equal to Laplace of sin 2t into Laplace of cos 3t. That type of calculation is not allowed. Therefore, what we have to do here, we have to convert this product sin 2t cos 3t by using this. For that, we have to multiply it by 2 and divide by 2. Adjustment. Therefore, it is 1 by 2, and then applying 2 sin A cos B. 2 sin A cos B is sin A plus B. Here A is 2t, B is 3t. Addition of these two, it is 5t plus sin of A minus B, 2t minus 3t, we get minus t. Okay. And then further simplification, it is 1 by 2 sin 5t, and sin minus theta is minus sin theta, means it is minus sin t. Okay, means this product I have converted to a sum, and then we can find the Laplace of this, means Laplace of this. Therefore, Laplace transform of sin 2t into cos 3t means the Laplace of this 1 by 2 times sin 5t minus sin t. and therefore it is equals to 1 by 2 constant. By that property of linearity we can take it outside, and then individual Laplace, Laplace of first term minus Laplace of second term, Laplace of sin phi t minus Laplace of sin t. We go step by step, and therefore it is equals to 1 by 2 Laplace of sin phi t. Applying this result, a upon s square plus a square, a is here 5, s square plus 5 square minus again a upon s square plus a square, a is here 1, s square plus 1. Okay, we can keep this as it is, or we can simplify it further by cross multiplication or by finding the LCM. Here I am keeping as it is. Then next, find Laplace of sin 3t into sin of phi t. Here it is again in the form of product. It is not equals to Laplace of sin 3t into Laplace of sin phi t. If you perform like that, then it becomes wrong. Therefore, what is the correct way? By applying this. Therefore, sin of 3t into sin phi t. Once again, I will multiply it by 2 and divide by 2, so that we get it is 1 by 2. 2 sin A sin B. Applying this result, it is cos A minus B minus cos A plus B. Therefore, it is cos of A minus B, 3t minus 5t. We get, and minus cos of A plus B, 3t plus 5t. We get 8t. Further simplification, 1 by 2. We know that cos minus theta is cos theta, and therefore it is cos of 2t minus cos of 8t. Okay, and then we find the Laplace of this, means the Laplace of this, and therefore Laplace transform of sin 3t into sin phi t is Laplace of this. 1 by 2 I will take outside directly. Laplace of the first term, cos of 2t minus Laplace of cos of 8t. And therefore it is equals to 1 by 2. Applying this result, its Laplace is s upon s square plus a square 2 square minus s upon Laplace for this s upon s square plus 8 square. 8 square is 64. This is the required Laplace transform. I can simplify it further. Next example, find Laplace of sin of omega t plus alpha. See, whatever the formula we have, it is for only sin at, and here it is sin of omega t plus alpha. Therefore, we have to expand this by the formula. We know that sin A plus B as sin A cos B plus cos A sin B. A standard trigonometric formula. for the expansion, and therefore applying this we get sine of omega t plus alpha, as here A is omega t and B is alpha, and therefore it is sine of omega t cos of alpha plus cos A cos of omega t into sine of alpha. Okay. Then next step, taking Laplace on both sides. Therefore Laplace of sine of omega t plus alpha and Laplace of right hand side, and I will take individual Laplace. Laplace of sine omega t into cos alpha plus Laplace of sine alpha into cos of omega t. Then it is equals to, applying the property of linearity, cos alpha and sin alpha are the constant term, therefore that constant term I will take outside. We get cos alpha Laplace of sin omega t. Here sin alpha is constant term, outside Laplace of cos of omega t. Okay, means we have converted to this form so that we can use the standard results, and therefore it is cos alpha, applying that Laplace of sin at, a upon s square plus a square, a is your omega, s square plus a square omega square, plus sin alpha, Laplace of cos at, s upon a square plus a square is here omega square. Denominator is same for both, therefore taking LCM we get s square plus omega square. We get omega cos alpha plus sin alpha into s is the required Laplace transform. Then problem based on this, find Laplace of t square, then find first of all I will complete this. Here t raised to n, n is here 2, and therefore applying this result, Laplace of t square, here n is 2, 2 is positive integer, and therefore its Laplace is n factorial, it is 2 factorial divided by s raised to 2 plus 1, therefore 2 factorial is 2 divided by s cube. Okay. Next, find Laplace transform of t raised to 3 by 2. Okay. Here n is 3 by 2, not a positive integer, therefore we have to use this first result. Laplace of t raised to 3 by 2, it is gamma n plus 1, n is here 3 by 2 plus 1 divided by s raised to 3 by 2 plus 1. This becomes s raised to 5 by 2, and then we have to simplify it by using this standard result. Gamma n plus 1 is n gamma n, therefore n is here 3 by 2 gamma of 3 by 2, it is equals to Once again, that gamma n we have tried down in the form of n plus 1 to obtain its value. Therefore, this 3 by 2 I can write it as 1 by 2 plus 1. It is equals to 3 by 2. Once again applying the same result, it is n gamma n. This time n is 1 by 2 into gamma 1 by 2 divided by s raised to 5 by 2. And then it is equals to, simplifying it, it is 3 by 4. Gamma 1 by 2 standard value, it is root pi, and divided by s raised to 5 by 2 is the required Laplace transform. Therefore, these two results are very, very important while finding the Laplace transform. Then we find Laplace of t minus 1 bracket square. Therefore, directly we can't use this before finding the Laplace transform. Therefore, t minus 1 bracket square a minus b whole square. Using that result, we get its expansion as a square means t square, twice ab 2t, and plus b square 1. And then we can use this result. Therefore, taking Laplace on both sides, Laplace of t minus 1 bracket square means the Laplace of the right hand side term. I will take individual Laplace, Laplace of t square, 2 constant outside, Laplace of t, and plus Laplace of 1. And then applying the standard result. Laplace of t square, n is here 2, positive integer. Therefore, using this, it is 2 factorial divided by s raised to 2 plus 1, it becomes 3, minus 2. Laplace of t is, again here n is 1, 1 factorial divided by s raised to 1 plus 1, 1 plus 1 we get 2, and Laplace of 1 by s. This is the required Laplace transform. Therefore, in this video, I have explained very simple examples to know how we can use this standard result to find the Laplace transform.